Okay, hi, Assalamualaikum. We are from Group 2B. So today we present about the pressure control experiment by using MATLAB Simulink. So my name is Muhammad Safwan bin Anwari and my matrix number is 192074.
My name is Husna Khairiyah binti Abraham Khair. My matric number is 192445.
Hi, my name is Taharim Hossain Rafin. My matric number is 191580.
Hi, my name is Mama Iman. My metric number is 191962.
Hello, my Muhammad Ahmad Mustaqim bin Nazar. My matric number.
Okay, I will start with the introduction part first. First of all, many processes industries were in need of smart controller that could bring the best performance for their modern plants. This experiment was particularly about pressure control, and pressure was in fact the second most measured parameter in process industries. For example, pressure measurement was used in areas such as storage, pumps, compressors, and so on. Thus, it was very important to measure pressure accurately to get the best quality of the final product and quickly control the dynamic process. One of the equipment that has been used to get an accurate result for pressure measurement was the ID controller. So I will pass the presentation to Safwan.
Okay, thank you, Husna. Okay, I will explain how to run the MATLAB Simulink. Okay, firstly, I will show the mat file for this pressure control. So it is the mat file for the pressure control. And then how to run it, we click the run button here. And then the MATLAB Simulink model will come out. And also the figure. So the figure is pressure versus time graph. So that's how to run the MATLAB Simulink model. So that's all from me. Thank you.
So thank you, Safwan, for the presenting the method. Next, we go to the graph. Asal aku tak boleh present lah?
Wait. Okay, try.
Okay, now we go into the result and analysis. For the first graph, if you can see the graph for the P controller value as the manipulated value, and the I and D controller is the constant value. The range for the manipulated value for P we use from 30 to 50. As you can see, when we increase the P value, the amplitude of the graph will decrease. Next, for the second graph, we use the I controller value as the manipulated value, and the P and D is the constant value. So the range that we use for the I value is the 10 until 30. So if you can see, when we increase the value of the I, the graph for the x-axis will closer to the reference point. Next, for the third graph, for the is D controller value is as the manipulated value, and P and I is the constant value. So the range that we use is for D is 0 until 2. If you can see, when we increase the value of the D, the amplitude of the graph will decrease, and the time will decrease also below than 1. And next, the last is the optimum value. We use the try and error value and change the P, I, and D controller until the graph closer to the reference value, and the result that we get is P is 35, I is 60, and D is 20. That's all for me.
Okay, I'm going to explain the discussion part. Finally, after analyzing the pressure of the system were done, as we can see, there were three graphs. From the first graph, we can we get that the most cohesive linear graph where every time P was varied, the pressure was almost close to each other. Thus, it proves Kp will result in increasing the stability of the system, reducing the overshoot, and improving the transient response. The next graph shows the pressure for each value of I increase at the same time, but when it reaches after 4 seconds, the pressure started to vary and makes the graph look incoherent. And lastly, the third graph, after analyzing, we see that slight changes were made in pressure when the Kd were increased. Thus, it makes the lines to almost near each other. However, it shows that higher the Kd, the faster the system reaches a higher pressure. That's all from me. I'm going to pass to Takim for conclusion.
Okay, thank you, Tarim. For conclusion, this experiment currently which is graph of Pi, Pd, and Pd. For P parameter, when P was pressure control will decrease. When integration parameter which is increase, pressure control will increase. Then when D parameter value increase, the pressure control will slightly decrease. It's shown that those I and D parameter had give effect performance of the optimal system. That's all of the group. Thank you.
Okay, thank you.
Thank you.
To Doctor, sorry for the internet poor internet connection. I hope you can accept this video presentation. Okay, thank you.